Okay, so 4.7. It says dilatation, but like I guess this is what like the active
Dilatation.
dilatation. Yeah.
Yeah, you sure it's not dilation?
Yes, that's what the book says.
So
So they talk about dilate. So this is like before we were preserving distance now, right? And this one doesn't preserve distance. Okay.
So is it an affine transformation still?
It's similar triangles.
Dilatation is active dilating.
So
Dilation is active dilating.
so the segments should all be in some ratio, right? Yeah, where K is called the ratio of magnification. So it's a similarity. It could be greater than or less than 1. Then you could use the word like magnification, blah, blah, blah. So you can define a similarity to be a transformation that preserves ratios of distances. And this implies both collinearity and angles are preserved. Is that obvious? Because then you preserve similar triangles, right? But is it obvious collinearity is preserved?
Linearity.
Well, if angles are preserved, then parallel lines with different lines.
Angles are preserved, so I guess collinearity is also preserved.
Yeah.
Why the hell are you in front of me now?
What?
Get out!
So the scalars, right?
Get out! What
Okay, so well, I mean, maybe we should discuss this. Is it obvious that so if you have 3 points, right? And the ratios of the distance, or if you have points and the ratios of, so let's just talk about this. Okay? If you have a transformation that preserves ratios of distances, does it preserve collinearity and angles?
Yeah. Because like it preserves similar triangles preserve. You mean it's just scaled up and down?
Duh.
It just has this property. Any two segments, right? The length, if this is A and B, right, satisfies.
The vectors, right?
They're just points in the plane.
Okay.
But the length, is that moved in any way? Is it translated in any way?
So if it gets bigger, then what happens?
So it either gets bigger or gets smaller, but it doesn't really matter because the inverse will make it go smaller if one of them goes bigger, right? So it's not as obvious as you say, I guess.
No, it's translating the shape across the plane as well as taking the
Translating it and making it bigger or smaller?
That's so obvious, right? That's like I see every single line. You can like do something with it. You multiply by constant and it just changes length.
No. It's not. We haven't assumed that they stay on the same line, yeah.
Oh, okay.
So you have the 2 points. They go to another 2 points. The distances happen to be related like this all the time, no matter what the
Well, I
points
guess
are, right?
the angles don't get preserved.
The angles do get preserved, but why? Why did the straight lines get preserved? If the straight lines get preserved, then the angles get preserved, right?
They're the same gradient.
Well, are you talking about triangles only?
Yeah, what the hell's that?
If the point rotates, then like one other point's through it. So like if this AB goes like this longer in time.
But how do you know the points in between go to the points in between?
Why can't you just some for example some AC on C on AB such that because A prime like C prime.
So how can you show it's collinear, right? So if you have a point C, okay, what you want to show is that C prime lies somewhere in, well, it could be in between or it could be,
Outside.
yeah? But like the point is, it only preserves something about distances. Yeah. So you got to know about the distance. So like here, you draw a circle, right?
Oh, I get it. You draw another circle.
Where's center? B.
Huh?
It's
Yes.
And
center
then you draw another circle. So it
Center
has
A, right?
Yeah.
preserve.
Oh my god, epic. Okay, sure.
Deep breath.
So this is not in the book, I don't think, because they said they probably thought it was too obvious to even explain. But it's not that obvious. I mean, it's a logical thing. Okay, so I mean, the point is like, if this is like, you know, what would you call it distance?
Let's see. Let's look.
K and L, yeah.
Yeah.
These are these.
Yeah, KZ. I should stick to these.
Just do
And
X.
Y.
Just use lambda and mu.
Use
Why?
mu and mu.
And then we have
X.
Use the new mu.
Funny joke.
so A prime and B prime, yeah. Now,
Now
what
you
does that
just
mean?
have
It means so
AC prime would be okay.
so C prime would have to lie on a circle around B prime, right?
Yeah.
Of radius
KY.
KY, yeah? That makes sense?
Yeah.
And then
There'll still have to be tangent.
Yeah, that's obvious, right?
So it's just in
well, the
C
point is
dash
x
one.
plus well, this is x plus y, right? So this has to be kx plus y.
And then you scale
So
up.
that's kx plus y. So then C has to be here, right?
Yeah, because if it's at any other point, it'll be longer than kx plus y.
Yeah.
Okay, yeah, sure.
Okay.
Why?
What?
X.
Because C is
No, no, he's not talking about the maths. He's talking about David.
Oh,
Oh, okay.
That is a
That
question that we
makes a lot
cannot
of
answer.
sense.
What do you mean why? What does move it? Deal with it.
Why do you have to put your feet on the wall?
I don't know.
Just take it off. Thank you. Alright, so, does that make sense? So now you actually preserve triangles. Yes? Because if it didn't stay on the same points, and it didn't stay inside, right? See, now if you had a triangle, yeah? And you sent it, so ABC, and you sent it to A prime, C prime, B prime, yeah? Yeah?
Yeah.
Well,
So they're similar.
you know, like A prime, B prime has to go to some fixed length now, yeah? But they could go anywhere, but that is alright. But then C is sort of fixed relative to A prime, B prime, because now it's like the intersection of the circles, right?
Yeah.
It can only go to two places. And all the points in between, okay?
Oh, the two places are the reflections, right?
And all the points in between have to go to points in between because we just showed that, right?
Wait, like the 2 points is the intersect the 2 points. 2 points are the reflections. C dash and C dash dash is the other side of AB. You can draw it.
Yeah.
Yeah, I guess that's how it works.
But in either case, you get a similar triangle, yeah? Because all the lengths are in the proportion. Yeah?
Wait, why does? How do you find point C?
For example, like, if you have a C here, right?
Yeah.
It has a distance, yeah? So it's the intersection of two circles.
Yeah, like the pivot triangle.
Yeah?
Yeah.
So it has to lie on the intersection of these two circles, right? So it has to lie on the intersection of a appropriately magnified radius. There. It could be on the other side, yeah. But similar triangles can be on the other side too. Yeah, so it could be here even, right? So the point is the edges all have to go to the edges, right? Yeah? Because we just showed that. And so you have two similar triangles now, right? So the angle is also equal, the corresponding angle, right? So the angles are preserved as well. Okay. So this simplest kind of similarity is a dilatation, so a dilatation, I guess, which they define to be something that transforms each line into a parallel line. the simplest kind of similarity is a dilatation. Sorry. So this is an even more special case of a similarity. A dilatation is something that just basically changes something to a parallel line.
What? To any parallel line.
So like A prime B prime is parallel to AB.
Oh, that is.
So let me just write the next
But
one.
when you transform a triangle, are you transforming the individual lines?
All the points on the triangle, yes.
So what if it happens to get broken up? Like what if the triangle like separates into 3 lines that doesn't form a triangle anymore?
Yeah, that's what I just showed you. It doesn't do that, right? The 3 points go to 3 points, and the points in between go to points in between. Similarity. The dilation takes a parallel line. So I guess the condition would be AB prime is parallel to AB. Yeah?
Is that it?
Oh, actually, there is one case that we might want to think about for your question. So is it possible for a triangle to collapse into a line?
And that's what I mean, like playing it with this stuff. It doesn't form a triangle at the other side.
You gotta actually think about it. So it can't because it's invertible, right?
Oh, okay. Well, these are invertible.
So lines go to lines, right?
Yeah.
So if it collapsed to a line,
Then
the line had to go back to a triangle when you invert it, right?
and that's
So that's not possible.
So
But that's
has
the
to-
only other case.
it has to be invertible.
Because if you have 3 points that go to a non-collinear 3 points, right? Then the edges would have to go to the edges. We just showed that. And then you get triangles go to triangles. Okay, so you have so a similarity is anything like this. So a special case of a similarity is a dilatation, dilation. So it takes a parallel line to another parallel line. If it's not a translation, then it's called a. If it's not a translation, then it's called a central dilatation. You know what I mean when I say not a translation, right?
That means it scales.
So basically, it doesn't fix the length. Yeah. Yeah, okay, so can you see if you have a central dilatation, right? So the reason it's called central, okay, basically if you have A and A prime, yeah? And sorry, maybe A and B. And it goes to like another parallel segment, A prime, B prime, yeah? Yeah, like that's you. Yeah?
What?
What?
Stop touching the door.
Okay.
Yeah.
Well,
You can also go home if you want. Alright, so the reason it's called a central dilatation is if you join these points up, okay,
Oh, okay. It comes up to this.
it always meets at like,
Oh, okay. So like if it's preserves distance, then it won't ever do that.
yeah,
duh.
because it'd be parallel, yeah. Now, that's a good observation. So it's not just these two, it's any pairs of points. You know what I'm saying? Like all the points and their images go to the same point. Does that make sense?
is not needed. Let's see about
Well, the O is unique for each function.
function.
Well, I mean, transformations are functions.
So once you fix the transformation, I guess the claim is
The O is not needed. Yeah, the AC then refers to
the A and the A prime.
Oh, also just points.
Yeah, so it's the point and its image, yeah? Does that make sense? So I guess to show this, you just have to show, well, any 2 points define where the O is, right? And then you just go show another third point also has to go there. Yeah? So the third point doesn't have to actually lie on this segment, right?
Oh.
The third point could be anywhere, yeah? It could be like here.
Because then it'll just be a triangle. And then it'll still be a similar triangle. And the C dash is
So I guess, can you see that actually C prime lies on the same line as OC, yeah? Yeah? Because it preserves collinearity, yeah? So I guess in this case we've assumed it lengthens it. Oh, actually, no. What am I talking about? This doesn't make sense. So actually, this is what we're trying to show, yes? It's not collinearity. Yeah, but we need 3 points for collinearity. We only have, well, I guess we can show O is fixed. No. 2 points can't show collinearity, yeah? We only have 2, so we only have O and C, yeah?
yeah. Don't we have C dash as well?
Yeah, so that's the image of one of the 2 points, yeah? So remember, we have 3 points that are collinear. The image of the 3 points are collinear, yeah?
Yeah.
So this doesn't show that they lie on the same line, right?
This doesn't show C dash as collinear.
Yeah, it doesn't show O, C, and C prime are collinear. It's just what we're trying to show. Okay?
AC and A prime C prime are parallel.
Yeah, that's right. So we're using the assumptions now. Yeah, so it's good. Sometimes it's important not to understand stuff, right? Because you can't understand stuff that's not true. So AC is parallel to A prime, C prime, yeah? Yeah. And then if we kind of just, so we don't pretend that they're collinear, but we can still join in the segment, yeah?
Yeah.
So we know the segment here is parallel to this, yeah?
To prove collinearity.
Oh, no, we don't.
You don't
No, we don't.
It is not parallel.
We don't know that. We can join this segment.
It is strictly not parallel.
It is, but it's
Oh,
not.
no, it doesn't really need to be parallel, I guess.
It is not parallel. Because these lines meet.
Yeah, they're not.
Exactly. Big bang.
Okay, so these are also parallel.
No, but you can't also say they're not parallel because you don't know that.
No. We know that they end up meeting.
Yes, Zing, they are not parallel.
But the thing things OC, C dash, you don't know if it's collinear.
Yeah, I know, but like, we will like we're aiming to show that, right?
But like,
And if you say that they're parallel, that means that they're not collinear. That means you've screwed up the question.
BC is parallel to B prime C prime. Useless information.
what do you mean it's useless information? It's very useful information.
How?
Drawing the other set of parallel lines. There's another set of parallel lines.
What is it?
BC and B prime C prime.
That's what you just said.
Haha, funny. Yeah.
But then like that's very useful information because alternate angles.
Yeah. So like now we know that the parallel lines, right? We have the ratio of the segments are equal, yeah.
The ratios are equal.
Yeah, that's what they say too. Yeah, so basically the segments are cut into a certain ratio, right? Yes. Which have to be cut in the same ratio here. Yes? Do we agree? But
Oh yeah, so OC prime has to.
yeah, like we know what the length of OC prime has to be, right?
And we have to
It's
prove
relative
if
to
we prove that OC prime is equal to OC plus C prime, then we can prove it's collinear.
What?
Yeah, so this is yeah, like this is X, right? How do you say this? Like this is X and this is Y, right?
The other one is K.
This has to be the same ratio X
and
to
KY.
Y. Yeah?
Wait, why does that have to be Y? Why is it the same distance?
Because this is parallel, okay? So this is ratio is still X to Y. Okay? So like so we don't know what the length so
Because it's similar. But we don't know OCC prime is collinear.
yeah, that's what we're proving. And we have it now. Look at this. So OA prime, right? Is equal to K times OA, yeah? Alright. So, I mean, the ratio has to be preserved by the parallel lines and by the similar triangles. Yeah? You know what I'm talking about? So if this is like X, right? This is like Kx minus X, yeah? Right?
AC is equal to Y. CC prime is equal to KY minus Y. AB is
Yeah,
equal
so
to
this
Z.
is Y, then this is equal to
KY minus
Ky
Y.
minus Y, right?
AB equals Z. BB prime is equal to KZ minus Z.
Yeah. But
And
the
OC
whole length you know is Ky,
Yeah,
right?
so OC prime is
Yeah.
the only one that.
So you know it's collinear. That's what I'm talking about. Like,
Actually, this is a little bit problematic. Did we do something wrong?
wait, what?
No, we didn't. Everything's alright. All as well.
No,
It's like if you have two.
let OC be Y, then OC prime has to be Y.
I'm a little bit confused now.
All as well.
You're a little bit confused. When Michael's a bit confused, then it's a
We're
bit.
all a little bit confused.
Confusion.
Confusion brews.
Yeah, so I didn't think.
As he says this thing.
Oh yeah, confused.
How does this,
So something's wrong with this argument, yeah?
why does this create?
So the argument doesn't work because. So the way we said it, right? we basically assumed it lies in a straight line to say the segments have to be in that ratio, yeah?
Oh, okay, yes. Like you can't just
No, but
hand wave that.
X mean
no, but OC. Since you dilate OC, you know OC prime. That should be KY.
Um,
Yeah.
yeah, but maybe not in the same line, right?
No, but it was just parallel.
prime is KY.
I mean, like it could be here and it would still preserve that parallel line.
Oh yeah, true. Rip. So we do know that that's the C front, right? Cycle though. See, what are you doing?
So what is actually the argument we're making here? So if we make this straight line go there, right? Yeah. Okay. Like,
Yeah, it should be parallel in the same way.
so that's a straight line, right? But we don't know that it goes to C prime, yeah?
But it's similar to like OAC and OA prime. The new thing should be similar to.
Yeah, but we do know the length of that has to be ky minus y, yeah?
Yeah. No, but, so like this triangle. This triangle is similar to this triangle, like this to that. Yeah?
Yeah.
Then white. That. And since OC prime is the only line in that.
Yeah, so I guess
Like
OC
this is
prime
X,
is the same length.
this is the KX, so these two are similar. Yeah? So this is
Yeah.
Y, this has KY as well. And
Yeah.
C prime is that.
So yeah, basically what you're saying is if you took a line from O to the parallel line, right? It would have length OC prime. Yeah?
Yes.
Okay. So C prime is also on the parallel line, right?
Yes.
Mm.
C prime.
It can be anywhere on parallel one.
Yeah, it can be. Thanks for this.
But the point is if you So, I mean, I guess now we're saying if you have a point that has the right distance, yeah, there can't be another point that has the same distance as that.
Oh, if it's but I don't know if it's perpendicular.
No, isn't that obvious by triangle in
Yeah, so this distance is always bigger than that distance.
Yes.
Oh, if it's
Plus
like
that
both
distance, yeah.
sides. Oh
Okay.
yeah, that distance is always very.
Yeah, so that would make that have to be C prime, yeah?
Yeah.
Okay.
Can you measure?
Using me, but
I think it should be said.
Zings, none. Oh, okay, sorry.
Yeah, so I guess it makes a comment that if you move O really far away, then it's kind of like making it a translation, right?
Huh?
Like if you're dilating some stuff here, and you make O like really far away, then it's as if it's a translation.
and using.
But that's just basically like saying like,
Why is it making it further?
yeah, that's just basically saying this part is almost like 0 length compared to the big part. So it's like k is kind of like 1, yeah.
Y times k minus 1. You are
Yeah. So
But why wasn't it just enough to show that because O, A, B and O, A prime and B prime are similar,
mhm.
and there's only one O, and then O, A, C and O, A prime and C. Yeah, that's what you did.
with Michael.
Yeah.
Did you say that A prime and C prime are the same words?
No,
Okay, but is that
because we're saying that that would make it parallel. Yes.
yeah, and it does not make sense because then it'd be
Yeah. Like
x is equal to y.
yeah, showing things that meet at a point are parallel. Okay. So yeah. So did you see the other case here? There's another case that's pretty similar. Like this. Is if you have O on this side. A and A prime.
It'll just be a negative,
Yeah.
and you can just reflect it back in this.
It's like that, yeah?
Yeah, it's just reflect it back.
Ah, yes. So that's C.
Yeah, but like negative K.
You have to show that this is the linear. Negative K. Yeah, I guess there's still some.
Why is it
Huh? Yeah, but they're still parallel, so you still get similar triangles, right?
Let OA be X, OB be Y.
And then I guess you maybe don't have a C prime yet, but just put something collinear. And then these are parallel as well. Well, actually, we don't know that. We can make it just pseudo parallel line with C prime, yeah?
So angle tracing.
the parallel of its OC?
Oh, similar switch. Okay, I get why there's a similar switch here now. If we join AC and AC prime, we find three pairs of similar triangles. Similar switch. Oh yeah.
These angles are equal, right? So they're similar, yeah? And then you have to put C prime here, basically. Okay. Alright, excellent. So we'll leave some of these exercises till after lunch. I really want to get through some of this next part. So that was 4.7, okay? I want to do 4.8 now. So I guess this is we're almost at the point of explaining some of the notation that we gave a summary for.